Hi, in this session I am going to discuss binomial distribution. Binomial distribution is one of the most important discrete probability distributions due to its applications in several business contexts. A random variable x is said to follow a binomial distribution when it satisfies these conditions. The first one is the random variable can have only two outcomes, usually labeled as success and failure, also known as Bernoulli trials. The second is the objective is to find the probability of getting k successes out of n trials where k is less than or equal to n. The third one is the probability of success is p and thus the probability of failure is 1 minus p. The fourth condition is the probability p is constant and does not change between trials. The fifth condition is that the trials are independent. Success and failure are generic terms used in binomial distribution. Based on the business context, the interpretation will change. For example, winning a lottery can be considered as a success and not winning as failure. The following are few examples of Bernoulli trials and associated with binomial distribution. The first example is customer churn, where the outcomes are customer churn and no customer churn. The second example is fraudulent insurance claims, where the outcomes are fraudulent claim and genuine claim. Third one is loan repayment default by a customer, where the outcomes are default and no default. The fourth is cart abandonment in e-commerce, a situation where the customer adds item to his or her cart but does not make the purchase. In this case, the outcomes are cart abandonment and no cart abandonment. The fifth example is employee attrition at a company, where the outcomes are the employee leaves the company and the second possible outcome is the employee does not leave the company. Any business context in which there are only two outcomes can be analyzed using binomial distribution. The probability mass function for binomial distribution, which is written as PMF of small x. So, basically the random variable, in this case binomial random variable taking value small x, which we can write as probability of x equal to x. This can be written as NCx p to the power x and 1 minus p to the power n minus x. So, this is the probability mass function for the binomial distribution. Here the value of x lies between 0 and n. So, in this case the NCx is getting x out of n is n factorial over x factorial times n minus x factorial. In Microsoft Excel, we can use the function binom.dist x n p false, which can be used for calculating the probability mass function of binomial distribution. The cumulative distribution function, I am writing that as capital F of a. This is same as probability that x, which is a binomial random variable, taking value less than or equal to a. So, what I can do is I can sum the probability mass function value up to the value of a. So, that will give me the cumulative distribution function. So, here the f of a is nothing but summation some k equal to 0 to a n c k p to the power k 1 minus p to the power n minus k. So, basically what we are doing is we are adding the probability mass function values up to the value of a. If we are using Excel to calculate the cumulative probability function of binomial distribution, then we can use the function binom dot dist within bracket a. Basically we want to calculate the probability up to a, and n is the total number of trials, p is the success probability and true. Remember, whenever we enter true here, it gives us the cumulative distribution function. Whenever we use false here, we will get the probability mass function. In this slide, as an illustration, I have probability mass function and cumulative distribution function of the binomial distribution for the parameter values n equal to 10 and p equal to 0.5. The mean and the variance of the binomial distribution is given by NP and NPQ. So, basically we can actually calculate the mean and variance using the generic formula for calculating the expected value or mean and variance. So, when we want to calculate for binomial distribution, remember the expected value for any generic discrete random variable is summation over x probability of x, or I can say xi probability of xi, and sum this over all possible values of the random variable. So, when we apply that for the binomial distribution, the expected value of binomial distribution is summation k equal to 0 to n, where k is the number of successes. The corresponding Moss function probability is nck p to the power k 1 minus p to the power n minus k, and we just multiply that with k here. So, when we simplify this, we will get the value as n times p. So, np is the expected value of a binomial random variable. Similarly, we can calculate the variance of the binomial random variable using the generic formula. In general, for a discrete random variable, the variance of x is summation over all possible values of xi minus expected value of x whole square, multiply that with the corresponding probability value. So, now we can substitute the expected value in case of a binomial distribution, which is np. So, here we can write this as k equal to 0 to n within bracket k minus np square, and the probability is nck p to the power k 1 minus p to the power n minus k. When we simplify this, we will get the value as n times p times 1 minus p. So, in many textbooks they write this as npq, where q is 1 minus p. So, there is a relationship between binomial distribution and normal distribution. If the number of trials n in a binomial distribution is large, then it can be approximated by using a normal distribution with mean np and the variance np times 1 minus p or npq.